Hello everyone, my name is Saiha and welcome back to another tutorial video by Project Leonhartz. So I went back to watch my series of tutorial on synchronization, and then I realized that there's a missing information about network view, and so I thought people who are not familiar with Unity's networking and uLink would be quite confused. So I thought I would make a video to fill up that gap. Okay, let's get started. So the first problem that I thought should be deal with. So the first thing is, how does the code here work when, for example, in synchronization script here, it is attached to all three objects in the client server and also proxies, and then I have only one script for all of them. Then how does the function, all of these functions run? Okay, so here's the deal. So for example, I have server sync here. This is supposed to be run by the server. So in order to stop other function to run this, I simply put a check at the top to say it's only if it's not the server, return. So yeah, anyone else that is not server will just not do anything. Only the server will get past that code and then run everything else. And for proxy, I just put if it's not a proxy, return. So yeah, that's how I segment all these all the code, and then yeah, just put them all together, but then still being segmented and then only run by the correct components. And the second thing is the RPC. How does RPC here work? So for example, I want to send in this case, this is owner. The owner is trying to send the position and rotation information to the server, and then so I use these unreliable RPC method and I put in the name. So that's how it works. So you have to use an RPC, and then you put the name of the function, which is this name. You have to match them, and then make sure you put this tag at the top here that say RPC to enable RPC call to this method. Okay, and then here is the mode. This is saying where you want to send this RPC. In this case, I want to send it to the server. There are many different modes. There are all that may be sent to everyone, including ourselves. And also buffered here, it means from the start of the game it will buffer this RPC, and then if there are any new instance join the network, it will receive all the buffered RPC. Others, that means everyone except ourselves, and then other except owners. There are many different options here you can use. That would cover like most of, I think should be 99% of your need, because I haven't met any cases that I cannot simply just use these options. Okay, so that's the RPC, and after this mode we just put all the data here that would be sent to the server or wherever you want it to go. So there are two types of sending the RPC. One, we have unreliable RPC here, and the other one is a reliable one, simply called RPC, and they have the same parameter afterward. So the unreliable one, just for those who are familiar with networking, it's called UDP. So it's a unreliable method, unreliable data transfer method. So it just transmit the data without doing any check whether the data already reached the server or not. Yeah, so that's what it does. It's just like transmitting a radio wave. And we normally do this unreliable method here on synchronization that have a constant rate of transmission. In this case, like in this case. I just send the data, keep sending it to the server every 100 millisecond. Yeah, so we don't care whether sometime it might lose a packet or not, so it doesn't really break the game. So it's okay to use unreliable here because it's faster than the reliable method, because the reliable method have to do a lot of checking. Okay, so yeah, you have to decide for yourself whether when you want to use unreliable and when you want to use reliable. Okay, and the next thing is called the network view. That is what enable us to use the RPC. As you can see here, to use the unreliable RPC here, I have to use NV, which is of type uLinkNetworkView. Here's the declaration, it's of type uLinkNetworkView. And then in the start method, I have to get that component from the game object. So that means we have to attach, no, that's the character, my bad. So here's the uLinkNetworkView, and that means we have the component attached. Here we go. This is my game object here. So we have to have it attached on all three objects, on the owner, the creator. I also have uLinkNetworkView here, and also the proxy. Otherwise, they cannot connect. They cannot communicate. So you have to attach this uLinkNetworkView, and to do that, you can go to add component, and if you have uLink installed, it should be under uLink basics, or you could go to this, I think. Maybe not, I don't know, never mind. Yeah, that's how you add it, or you can just go to the this plugin folder for uLink and then find the script here and then just drag it and drop on that object. Okay, so in order to send RPC, you need to have the uLinkNetworkView object onto the game object, and then you have to get its component, then you can send RPC. And in here you can see, here is the options for RPC. You can set it into different options. The default one should be this game object. That means RPC will be received by this game object here. But in my case, I choose this game object and children because because if you look into this, you can see I have some children here, though I didn't use it. But yeah, there are component inside this game object. In my case, is the inventory, which is the child of that owner object, and I want that inventory to receive the uLink network, the RPC from for example, the creator. So yeah, that's why I choose game object and children here. Okay, and what else? Oh, here's the very important part. This is very important attribute of the network view, which is the view ID. This is what link your object to each other. For example, I have creator, owner, and proxy here. How does that link between different instances of the game? For example, in a client, you have both the owner object and the proxy object inside one instance, inside your client. And maybe you have multiple proxies. For example, there are many other player playing, so you see them all. So you have a lot of these proxy objects on your clients. And how does it identify between one proxy to the other proxy, and then send the RPC to the correct object? And that is done using this network view here, view ID here. So this view ID will be set automatically. In my case, if you make it into a prefab like this, and then you instantiate them using the uLink in here in the server code. This is the code on the server where it instantiate the instance as the server and stuff like that. And then on player connect, on this player connect, it will call uLink network instantiate. and we have these proxy owner and creator prefab here to be instantiated, and then instantiate network instantiate here will set the network view, the view ID for each object to be the same to make them connected. This will be done automatically. So so this will be done automatically for you, so it's good. You just need to make sure they have the uLinkNetworkView and make sure that this is not set to manual. If you put allocated, then you allow it to be auto set. So yeah, you can see there's another option for manual. So when do we want to use manual? For example, we have NPC inside our game that will be owned by the server. In that case, we don't want to be instantiating all the NPC during runtime, right? And also the server will run all the time, so the NPC will stay on the server all the time. So it's better to just place the NPC inside the scene here from the beginning. For the clients, they will of course have to instantiate them on runtime, but yeah, for the server we want them all in the scene. No, on the client scene should be the same as well. You have all the even if you are on the client side, for example, you still need to have that game object, the NPC object, to be at the same spot as well to make sure otherwise they wouldn't be seeing the same thing as the server. That's not good. So yeah, for example, we have NPC, and then to link that NPC to the one in the client, you need to put it in, you want to put it in the scene like this, and then you have to change this to manual, the view ID as manual, and then you have to make sure that the view the view ID here have to be the same as the one in the client. Then it will be connected. Yeah, that's it's that simple. So okay, that's the network view. Whenever they have the same view ID, that means RPC here will be sent to that object. So yeah, uLink will check to find the one that have the same view ID, and then only send the message to that object so that it doesn't get confused with other objects. And there's another thing that you will see me doing in my script here. For example, I want this game object to run by the owner, so I need to use networkView.isOwner. So how does networkView know whether my game object is an owner or the server and stuff like that? Well, whenever you put the network view inside these components, inside these objects, it will also connect to the for example, the server script here instantiated my instance as a server, and that will be connected with the all the uLink network view components. They will know whether your instance is being run as server or not. So yeah, you don't have to do any setting like saying any there's no attribute in here for you to set whether they should be the owner or should be the server or anything. It will know instantly, so you just have to add the component to the game object and then instantiate it in the right instance. For example, you instantiate the object, the owner object, in the client, then this uLinkNetworkView knows that you are the client side, then the code here will know that you are the client, so it only runs the client function. It doesn't do the server part. Okay, so that's the idea. That's how it's all connected. There's also another feature in network view here called state synchronization. So you will be wondering, what does this do? It's called state synchronization. So why, when I do synchronization, I never use it? Well, if you look into the Snowbox project, maybe I'll try opening that. They were using that state synchronization feature in order to synchronize the position in the game object. But I didn't use it. I just use unreliable RPC. The performance, this seems to be doing the same thing. I checked the network, the packet that was sent every second, and they seem to be the same when I use state synchronization. And the RPC, yeah, they have the same rate, about 500 bytes for my character synchronization, 500 bytes per second. Okay, here is the Snowbox project. It's not the default one. I make some modification in this one, but if you check in the sources here, you will see uLinkNetworkView here, and they have unreliable state synchronization here. They set to unreliable instead of off, and also they have this observed. This is where state synchronization take place. So you have to put the script, the synchronization script, inside this observed slot, and then it will be synchronized using unreliable state synchronization. And the rate that it's sent is based on uLink setting here. Here's the state sync send rate as 15. That means 15 times per second. And there are a bunch of other options. I'm not sure what they really do, but yeah, you can check on them in the Unity documentation and in their website. But yeah, this is the rate here. Wait, what the? Sorry. Oh, maybe I just reset that. Okay. So what is inside this script that do the synchronization? That's gonna be, yeah, it's a little different. So I think I just show you that as well. So here, this is the synchronization. This is how you use that uLink feature for synchronization. It's in here. So you have the uLink on serialized network view, and that will allow you to check whether you are the streamer or you are the receiver. So in this case, in this function, the server will always be the streamer. So if you put streaming.isWriting, that means if it's true, then it is the servers, and then you just write these transform position, velocity, and rotation, etc. Whatever you want to send to the proxy. In this case, this is the proxy. This function here only connect from server to the proxy, as I checked the documentation. I was a little confused because I didn't know what is going on here, because it is attached to all three objects, but then this code doesn't run on the server side, so I was really confused. But then I find out that this function only connect from server to the proxy. In order to use the owner, you have to use another function. I think it's uLink on serialization network view owner. I think you have to check on the, I think that yeah, that's owner or something at the end here. It's a different one. That by default, uLink only sent this. uLink only run this method on the server and the proxy, and you have to use another method to be for the server to send to the owner. That is by default, but there is an option for you to set it to be sent to the owner as well. But I forgot what it was. You have to check the uLink website for that. So anyway, so here's the how it synchronized. So just check whether it's streaming. If it is streaming, it's the server, then you just send the thing. If it's not, then it's receiving, so you just read those states, read these variable into your own variable, and then store them, etc. So these are the same code, as you can see, as in my state character synchronization here, because I just copy them. Yeah, so yeah, that's the That's the code for synchronization that uLink use. But for me, I just check. I just use RPC. I just send RPC, and then the client, the proxy receive that, and then I store it. Yeah. And then here we do the same. And then we do the interpolation for the proxy. So yeah. What else? So okay, the server receive the in here the server send write the thing, stream the variable to the client at the rate that was set inside the uLink edit setting here. So the problem I have with this is that if you use all of these all of these features, I mean, if you use this feature for all of your game object for synchronization, they are all set using this one variable. That means they all will be sent at the same rate. So well, if that's what you want, then it's fine, but for me, I want some more flexibility. So if I use my own variable, I can set it in the individual state. I can set the synchronization rate here individually for every object. That means some object I don't want to send at 10 times or 15 times per second, but some I want to send at that speed. So here I have my own send rate variable. That means, yeah, I have more flexibility, and it would be good for optimization as well. For example, the object, for example, clients that are farther away from you, I want to update their position only maybe 5 times per second to reduce the network load. But people who are closer, we can send at a faster rate, at maybe 15 times per second. In that case, it would make it a lot better for the network optimization. But if you use this feature, it will be fixed by just one value, and I think that's not really ideal for me. Okay, so I think that is all. I hope this will help you understand all the network stuff with uLink, and also fill in the gap and help you understand what I was talking about in my tutorials. If you enjoyed the video, please don't forget to like the video, and if you haven't already, please subscribe so that I can get my channel more access to other people. I get it. Yeah, I totally need more help with publicizing my channel right now. I want it to grow bigger before I start releasing trailer for my game. Anyway, thank you very much for watching, and I hope you enjoy my video. I will see you in the next episode. Goodbye.